guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at a probability statistics question which is displayed to you already. It reads, show that the number of sixes obtained when two dice are thrown is a random variable. Alright, so this question was proposed to me by one of the students in the MAFA further maths revision groups, and most of the students actually faced a lot of difficulties in coming out with this proof. So in this video I'm going to explain detailedly what you are supposed to do. Alright, so let's get started. Alright, so the question is asking us to show that the number of sixes when two dice are thrown is a random variable. So the first thing is that we need to get all the possibilities of getting a 6 when the two dice are thrown. So there are three possibilities. It is either we get no 6, or we get 1 6, or we get 2 6s. So those are the three possibilities. So that capital X there represents our random variable, which we are supposed to show that it is actually a random variable. So our capital X there, it is either you have our capital X there represents the number of 6 that we are going to get when we throw the two dice. So it is either we get no 6, or we get 1 6, or we get 2 6s. Now I'm going to draw a table where we are going to get the various possibilities for the first dice and for the second dice. So for the first dice we have the total number of numbers. We have 1 2 3 4 5 and 6. For the second we have the same 1 2 3 4 5 and 6. Now when we throw the first time, we have either we have a 1 on the first dice, or we have a 1 on the second dice, or we have a 1 on the first dice and we have a 2 on the second dice, and so on and so forth. Now when we throw again, we can either have a 2 on the first dice and a 1 on the second dice, or vice versa. So you just need to fill this table because it is going to help us in this proof. Alright, now after filling the table, the next thing we are going to look at is our sample space. Our sample space is simply 36 because we have 36 total possibilities, meaning we have 1 2 3 4 5 6 1 2 3 4 5 6. We just multiply right and we get 36. So that is our total sample space. Now we need to get the various possibilities. For us to get no 6, for us to get 1 6, and for us to get 2 6s when we throw our two dice. Alright, so if we are supposed to get no 6, it means we are in this region, the region that is demarcated in the yellow color. So you see that for this region here there is no 6, meaning that the first dice and the second dice have no 6. So you have 1 1 1 2 1 3 1 4 1 5 till right up to 5 5. So if we count the total number of possibilities, you are going to see that for us to have no 6, there are 25 possible outcomes. So it means the probability of us getting no 6 is simply the favorable outcomes, which is 25, divided by the sample space, which is 36. Now the next is for us to get 1 6. If we are getting 1 6, it means that it is either the first dice has no 6 and the second dice has a 6, or vice versa. So we have this region which is demarcated in green. So we have this, 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 and we have this. So in essence we have a total number of 10 possible outcomes. 1 2 3 4 5 6 7 8 9 10. So for us to get 1 6, we have 10 possible outcomes. So the probability of us getting 1 6 is the number of favorable outcomes, which is 10, divided by the sample space, which is 36. And finally, for us to get 2 6, there is only one possible outcome, which is when both dice show a 6. So it means the probability of getting 2 6 is just the total number of favorable outcomes, which is 1, divided by the total number of outcomes, which is the sample space, which is 36. Now if our x here actually defines a random variable, then the first thing is that it should be a discrete random variable, because we are going to involve ourselves in summation here. So we are going to create a table where we have our x 0, 1 and 2. That's the possible number of 6 that we can get, and then with their respective probabilities. For x equal to 0, we have 25 on 6 on 36. For x equal to 1, we get 10 on 36, and for x equal to 2, we get 1 on 36. Now if this is a random variable, it means that the sum of all the probabilities should give us 1. Alright, so if we sum all the probabilities, we get for 0, for 1, and for 2. For 0 is 25 on 6, for 1 is 10 on 6, and for 2 is 1 on 36, on 36. So summing all, we get the probability to be 1 at the end. So it means that our x here, which defines the number of 6s obtained when 2 dice are thrown, is actually a random variable, and specifically it is a discrete random variable because the sum of all the probabilities for the different outcomes give us 1. Alright, so that's that for the question. Thanks for watching. See you in the next video. Make sure you like the video, share the video with your friends, and subscribe to the channel. Thank you.
That's it.
I've received it.
Take this for transport. So can I have your number?
No, I don't do that.
I just made a transfer of 100,000 to you. You're saying you don't do that?
Yes.
Is that how you do?
Yes.
I'm an investor. Your number now.